construct a simple Ohms law shape. For that, just go to MathWorks, type MathWorks in Google, and you will be directed to this web page. That is the first link. Click on the first link. Once you click it on, it will direct you to this home page of MathWorks, where you have to click on this MATLAB button. Here you have seen the MATLAB button, and I have already logged into my login, therefore it shows my profile picture. If you want, you have to log in before clicking on this MATLAB button. Now it shows like this, and here you have to click on this Open MATLAB Online. Now I am going to show you how to construct this Ohms law circuit in MATLAB in online platform. Okay, if you want it in do it in offline platform, you have to use this install MATLAB. You have to install the MATLAB software, and then you have to construct the circuit. Okay, in the same procedure, I have already uploaded my video in this channel regarding how to install MATLAB. Now I am clicking on Open MATLAB Online. Or it will show you like this. Here you have three tabs, that is Home, Plots and Apps. You have to click on Home. Under the Home, you have to click on this New button. Okay, it is shown with the plus symbol, New. Here you have to scroll it down. At last we will be having the Simulink model. Just click on Simulink model. It will show you like this. Here you can have blank models of different toolboxes, but here we need to create a model that is under Simulink, which is the blank model. Okay, blank model, you have to create a model. Just click on this blank model. Now your blank model is open. This is a page where we have to construct the circuit. It is named with the title, which is untitled. It is named with the name untitled. You have to now save the file. For that, here we have different tabs. Under Simulation tab, you have the Save button. Just click on Save button. You can save in the MATLAB drive, where you can rename this file as Ohms law, OHMS, and for to separate two words you have to use underscore, K I can use. This is my file name, and save. If you leave some space between the two words, it will show you error. Therefore you have to mention name without space. Now save. My file is saved. That is Ohms underscore K. This is my file name, and here we have to construct the Ohms law using Simscape elements. For that, you can open this library browser and you can search. There are three different ways you can search the components. We have already discussed in the earlier videos how to search components and how to bring the components to the workspace, that is the construction area. Here the first way is, here there is a search box available. under the search box you can type the element name. For example, DC voltage source, you can type without spelling mistake. Just search, click on enter. It will search for DC voltage source. It will bring you all kind of DC voltage source, that is either a Simulink as well as Simscape elements as well as some other DC voltage source from some other tool boxes. Everything will be brought to this area. From this you can select what type of DC voltage source you need. You have to select, or you can also search by this library. Okay, that is you have to go to this Simscape. Under the Simscape you have to choose foundation library. Under the foundation library you can choose electrical and electrical elements. Electrical elements, you have different elements as well as electrical sources or sensors. Electrical sensors, we have current sensor, voltage sensor, as well as electrical sources, you have AC voltage source, DC voltage source, control current source, everything will be available. You have to choose under foundation library. That is very important. That is a pathway you have to maintain. Okay, that is Simulink foundation library, and then electrical. Under electrical, different categories available: electrical elements, electrical sensors, electrical sources. Okay, from that you can choose the element and you can add to your workspace. Okay, here if I want to add this element, you can just drag the element to this place, or you can right click on the particular element. Okay, you can drag. Now you can drag and drop this element, or you can right click on this particular element and you can add to the model. Add this block to model Ohms _ K. This is my model name. You can click and you can add. Okay, this is another way, the second way to search the elements. Okay, the third way is very easiest way from my point of view. That is just left click on any empty space. Just left click on any empty space and type the element name. Now you have typed the element name, you can type as full name, or partially if you type, it will show you it will show different suggestions. Okay, under the suggestion you have to choose the element under foundation library. Okay, this is our element. First one is not the required element. The second one is my required element. Okay, both are both will be like the similar one, but under foundation library we have to choose the element. Okay, the second one I have chosen. This is one of the element. We need to construct the simple Ohm's law circuit. Second, I need current sensor under the same foundation library. I have taken the current sensor. The third one, I need resistor. That is also from foundation library, and you can rotate by clicking on Ctrl+R. If you want to flip, you can use Ctrl+I. And then we need solver. That is very important. That is the element that will use to solve the particular calculation in the given circuit. An electrical reference, that is also very important. That is, these two are the common elements for any Simscape circuits. If you want to develop any circuits, you should use solver configuration as well as electrical reference. Okay, now to complete the circuit for simulation. And then voltage sensor under foundation library. This is the way you have to arrange. Okay, now you can connect this current sensor. Why? Because the current sensor should be connected in series to the voltage source as well as the resistor. Okay, here the resistor is this is the load and this is the source, and this is my this manner you have to connect. First you have to connect electrical reference, then connect the solver to the electrical reference, and now it is the voltage sensor positive to connected to the positive of resistor, negative to connected to the negative of the resistor. In this manner you have to connect. Now if I have just connected the measuring elements, that is I have just connected the sensors, that is the sensor will sense the current, and this sensor will sense the voltage, okay, that is voltage sensor. Now you have to measure the value and display. Okay, these blue color components are nothing but the Simscape elements. Okay, whereas I want to display the value, so I have to choose the display block. Okay, I have to choose the display block. This is my display block. Okay, these display blocks are Simulink components. Okay, so I have to use the component which converts Simscape parameter to Simulink parameter. Okay, therefore I am using our system to Simulink converter, PS to Simulink converter, PS-Simulink converter. This component I have to use. The same has to be copied here. Now connect this to this third terminal of current sensor and to display, and here the third terminal of voltage to this PS to Simulink converter, and it is connected in this fashion. This is my complete circuit. As well as you can include the annotations. Okay, you can include annotations like verification of Ohm's law, like this. You can create annotation. Here you have to check on create annotation, like this. You can include verification of Ohm's law using MATLAB Simscape. You can add like this. You can type the annotations. You can change the font also. You can change the font as per your requirement. You can increase the font size as well. You can bold, as well as you can change the color of the font. You can justify everything. You can do in this manner. You can adjust like this. You can have the simulation, the complete simulation for better view. Also you can add name for this particular elements. For example, this is Vs or V in. I can choose it as V in, input voltage, and this is my load. I can type like this, or you can make it as source load, and this is my current measurement. Current, just I can type it as current, that is enough. And this is my high current in ampere. I can represent in ampere, bracket ampere. I can represent like this. Here also I can represent like V in voltage. This is how I can represent. See, this is the complete circuit of Ohm's law. Here you can change the value of source. For example, it is 10 volt. I can choose, and here I can choose the ohms to 2 ohm. So you can choose the ohms value as 2 ohm. I can choose. Now you can run the simulation by clicking on this simulation tab. Under the simulation tab, you can run. You can set the stop time also. By default it is 10 seconds. We can make it as keep it as 10 seconds, and now run the simulation. It will first compile and it will show you the value. Okay, here the current is 5 ampere. Why? Because we have set 10 volt, and then 2 ohm is the resistance. Okay, 10 divided by 2, which is 5 ampere, and the voltage across the resistor is 10 volt. Why? Because these two are connected in parallel. Okay, accordingly you can change. Okay, you can have 3 different cases, like In the first case, you can fix the voltages constant, and you can vary the load. Okay, resistance you can vary for different distance. For the fixed voltage, you can analyze the performance of the circuit. That is how about the voltage, the current variation. How about the voltage is almost similar, whereas the current will changes. Okay. Similarly, you can change the voltage and you can maintain the resistor as constant, and you can analyze the performance. The third one, you can change voltage as well as current simultaneously, and you can analyze the values of the current. Okay, this is how you have to construct as well as you have to verify the Ohm's law using MATLAB Simscape. Also, I have given this complete circuit in my file exchange platform. This is my already simulated as well as uploaded simulation in file exchange. Here you have three options. Here you can share this file to your friends. That is, you have two different options. Direct link is available, as well as you can give the MATLAB Online link. Okay, both are available. You can just copy as well as you can send it to your friends through WhatsApp or Instagram, anything. Or you can use this open in MATLAB Online. Just if you click on this, it will directly open. Okay. Or you can use this download button. If you download, it will download the file. Okay, it will download the file, like the zip file will be downloaded. If you unzip the file, you will be having the actual simulation file, that is a .slx file will be available. Okay, this the Ohms underscore triple K will be a .slx file. This will be stored as .slx file. This simulation will be stored as a .slx file. I will show you how to open this MATLAB Online. Okay, here I have to click on this open in MATLAB Online. Once you click it on, it will be opening. It will take some time. The same process will continues. Here it will asking for save a new copy. The already existing file will be available. It will show you where you have to store. Okay, you can select the save location and you can choose. You can check in this. I understand the risk of saving. The same you have to check and save and open. If you click on save and open, here in this file location side you will be having Ohm's law, Ohms underscore law you will be having. Just click on this Ohms underscore law. You have to double click and it will be open like this. This is the actual file you can get by clicking on this file exchange link. I will share this link in the description also. You can just click it and you can run the simulation as it is without any construction. Just you can change the value and you can see the performance of the circuit, how the current or how the voltage will be, like that you can check by simply changing the resistor as well as voltage. This is about the verification of Ohm's law using MATLAB Simscape. Thank you.